Hello, today I want to talk about Einstein's theory really quickly. I want to talk about some of the things he realized with his theory of relativity. I want to shake off some of the confusion around it, some of the mysticism that I think keep people from understanding what he was talking about. It's very simple. He was talking about two objects in space and their relative position to one another. Basically, that's what it is. The calculation that he came up with in earlier theories uh, with movement and with relativity is E equal mc squared, where E is energy, m is mass, and c is the speed of light, and c squared would be the speed of light squared, a very large number. The first thing I want to tell you is you do not need the speed of light to use that calculation. If you invert the calculation, you would find that m equals c squared over e. Why is c squared in that position all by itself? And the reason is it doesn't have to be. It could be any number. The answer that you receive is simply going to be in the scale of whatever constant number that you put in place of c. And that could be any number. It could be 1, it could be 2. I would say, just logically to me, it would make sense that the higher the number you use in that position, the more accurate your predictions are going to be of the path of a planet that's light years away if you're trying to predict its path, its forward path. Right now we're doing that, and we're a little bit off when we're predicting the path of planets or entire solar systems. You know, the universe is constantly expanding in most areas. What I would say behind us. Um, that's a fourth dimension reference that's not really important right now, but let's say that when we're observing a planet that's possibly tens or hundreds of light years away, and we're trying to predict, we can see that it's moving, and we can see its path that it's taken in time, space-time thing. Okay, that's where that falls in. We can see its path as it's been taking, and we want to predict its path because we can see it's coming up to perhaps another galaxy or a cluster of other solar systems. Well, there's an amount of gravity that's going to be involved with those other solar systems that are going to affect the path of this planet. And in order for us to predict that exact path, to give us some kind of idea of which direction it's going to flow in the future, we have to use gravitational equation. And that's what I want to talk about here in this video. Gravitational equation, or something that I'm going to start referring to as gravitational signature. We have our own solar system. You know that. We have a sun. We have several planets that rotate around the sun. We live on one that does that. Our planet also rotates every 24 hours. So a day in the life of the Earth in our solar system is 24 hours, give or take. Other planets have different day lengths. Some planets have no day lengths. Excuse me. So we're looking at our particular sun. The distance from us to that sun, the star, called the sun, and at the frequency at which that particular star emits energy, or what I will refer to as photons. It spits out photons in all 360-degree directions. The Earth happens to be always at some point in the path of those photons. The Earth is made up of 75% water. The other 25% is solid Earth crust. And so there's a whole bevy of different physiological things that are happening when a photon strikes an atom anywhere on the Earth or in your body or anything that's on the Earth, a tree or house or whatever. So we need to come up, to understand what I'm talking about, we're going to come up with a standard frequency of how many photons are hitting each atom on your body, I mean each individual atom, or on the ocean or in the river or on a house or on the earth or wherever, each atom is going to be hit by so many photons over a period of time. Let's say we have let's just make it simple and say there's 100 photons coming from the sun every second. And so a second of time is this big. Within there is 100 photons, and they're headed for every minute, micro, small little thing that's in its path. And the Earth has a whole lot of atoms, and if each atom gets hit by 100 photons every second of every day, given the rotation of the Earth, that part of the Earth is going to be half of the Earth is going to be dark at all times, and it's constantly moving. That also affects the frequency of energy that's striking the Earth. In my theory, energy striking the Earth is what causes gravity. That's the cause of gravity. Nobody has ever told you what the cause of gravity is. I don't know if my theory is correct or not either, but I do believe we have to start somewhere, and that is my understanding of gravity is caused by the energy we receive from the sun. And as it happens, we are in a very specific solar system with a very specific star that pushes out photons at a very specific rate. We are in a planet that turns on an axis at a very specific rate. And we revolve around the star at a very specific rate. So all of those things put together create what I call a signature of gravity. Very unique to the Earth, only the Earth. The moon is not made up of the same elements that the Earth is made up of. Well, I mean, it is made up of the same elements, but not all of the same elements. There's no oceans on the Earth. There's a lot of things on the moon that are not on Earth, and perhaps vice versa. We don't know that yet, but in any event, the moon is relatively close to the Earth. They're being struck by the same amount of photons, yet the moon has a different gravitational signature, and so will every other planet in our solar system. And so as we look outward and try to predict the path of a body like a planet or a solar system that's many light years away from us, and we try to predict its path, we have to consider the gravitational fields that body is headed into. Now, we can see through time that the body is moving. We can see which direction it has moved. We can justify somehow the difference in gravitational effect that has already changed that planet's or that star system's movement, because gravity will affect that body's mass and its movement. If it's headed into a cluster of different solar systems, all of those different solar systems are going to apply different forces of gravity on that moving body, and it's going to have an effect on its path. So to predict its path, we need to know the gravitational effects of all those other star systems and bodies that are surrounding the moving body. And that's hard to do, especially considering that we only have our own sense of what gravity is. We have a very specific gravitational signature here on Earth. It's not going to be the same as those solar systems that are light years away that are going to affect the path of that moving body that's light years away. So understand that we're never going to get an exact calculation, an exact path of that body. We're always going to be a little bit off, because gravitation as a whole, just like star systems as a whole, are similar to our own star system. But understand that each star is like a snowflake. It's going to push out different frequencies, maybe only slightly, but that's going to have an effect on each solar system's gravitational signature, and therefore each galaxy's gravitational signature. And that's 10 minutes 31 seconds. I just explained where gravity came from, I hope. If not, let me know in the comments. Keep it nice, people. I'm not here to be taught by you, so thank you for your desire to teach me. I'm an old dog and I don't learn new tricks. This is my trick. If you don't like it, build your own. Thanks.